Haroon Junaidi is the creator of one of my favorite YouTube channels, Electric Aviation. With a background in mechanical engineering and a PhD in renewable energy, he specializes in modeling and simulation, particularly in computational fluid dynamics. Currently working in the e-mobility sector, Haroon combines his professional expertise with his passion for aviation to advocate for sustainability and promote sustainable transport through his channel. And now, this is the second episode of Sky Zero Podcast. Haroon, I have to say how excited I am to have you today on the podcast. Thank you so much for making the time. Your channel, Electric Aviation, has been like a lifeline to me. When I first started hearing about the Pipistrel, it was the Alpha back then, and I wanted to know more. Like, were there others and these kinds of things? Like, finding your channel on YouTube was just like a godsend, a rabbit hole that I went really, really, really deep down. So I'm really excited to have you on the show today. Did I miss anything in your bio? Anything you want to correct or add?
No, I think that's about it.
Cool.
Thank you for having me. And it's the very first time actually I'm revealing my face. I've never revealed it on my channel. So that's exclusive for you.
Amazing. Maybe we'll have to do some sort of put the episode on both channels or something like this. That'll be up to you, of course.
Maybe we
Yeah,
can think about that. Yeah.
we'll talk about it for sure.
So I was checking, I've done about 112 videos by now, and I've never revealed my face before this.
Wow. Yeah, that's right. I can, and it's normally you with, I think one of the things that I love most about your channel is how you can cover a lot of information in a way that's very understandable and in a way that doesn't take very much time. You have a really concise ability to edit and to get it down to the essential facts and convey something that both like tickles my engineering-like imagination, but at the same time is understandable and sort of not too jargon-heavy in a way that's difficult to understand. So I really, you can sense the experience you've built up. What made you start it? Like 112 episodes ago. How long ago was this, and what got you started?
I started in October 2020, so we're just coming to 5 years now. But I really had to wait for to start this channel because I wanted the stories to come in thick and fast. Because you might know that for YouTube, you need to deliver content consistently. You can't just have a story there and then come back after 1 month and upload something else. You have to have at least, weekly content. So I waited till the time I got that because the electric aviation thing started in this sphere about, you can say, 2015 onwards. But there would be one story here, and then 6 months down the line, there would be another story there. It wasn't like you had a news that was consistent. So I had to wait a bit, and in 2020, I decided that yeah, it's time that we have a channel. I've got enough content on my plate that I can deliver to the audience on a regular basis. And round about the same time, there was a lot of excitement in the electric aviation world. There were eVTOLs was a fresh concept. Uber had released its urban air mobility white paper, and there were these new designs which were really really inspiring people all around the world. They were it was in aviation. You notice that innovation is very little, and to see something new, innovative, and fresh, people wanted to know more about that. So, around about 2020, a lot was happening, and further on 2 years, there were even more stories. So, that at that time, I thought, right, this is the time I got to do it right now. So
I
that's the
like that.
background.
So show you forethought and planning in terms of thinking about like, oh, I'll have to have weekly content. So you sort of had to have enough build up. Yeah. Okay. Cool. Yeah, that's amazing. So I think through the 5 years, you must have seen a lot of change, right? Like I haven't, I've been paying attention somewhat, but it's very recent where I've started to really pay attention. So you must have seen, how have things shifted while you've been watching? To sort of think about past, present, future arc. We'll get to future, but yeah, I mean, how have you seen it change so far?
I think we are in a passage of lull right now, because initially there was very high expectations that, oh, everybody is going to have their personal flying machine. But we are coming to the realization that the battery technology hasn't advanced as fast as we would have liked it to advance. And in the last 10 years in particular, we've moved to about a battery energy density of 250 to 300 watt hour per kilogram. So not a lot of change. And in fact, we have now reverted to batteries that are much less energy dense but are safer. Um, so we're still waiting for that solid state battery breakthrough. Um, so at the moment, it's a period of lull. But 3 years back, this sector was buzzing. Um, but what I see in the future is it might climb back up again. Um, with the advancement in the battery technology, there's some excitement there in lithium sulfur, the silicon anodes, and also the aluminum air battery.
Honestly, the aluminum air battery is maybe one of my favorites on your channel. I went and found that there was actually a Canadian startup, but they specialize in aluminum air batteries. And I checked out their, or fuel cells almost, you tell me, but I remember checking out their website and it was talking about like it could be used in telcos. I'm like, yes, of course, but you could also use it maybe in airplanes. And I emailed the CEO and said, you should think about aviation. My friend Haroon says so. I didn't know who you were at that time, but I'd seen your one episode on it. That was one of my things I wanted to ping you about. Like we've got to get into the aluminum air batteries, but I want to get back to your more the rest of your point. I do sense the lull, right? I mean, the way I experience that lull, and it'll be different because my own, dynamic through the path is just been a little bit different. But for me, the lull is like I remember thinking, oh, the aviation Alice was gonna, be coming out soon, and I think you and I talked about how Wendover Productions did they did a really great video on the aviation Alice and how. Oh gosh, I can't remember the name of the airline now, but there was this airline in the eastern U.S. that was going to buy a bunch of them, and I remember actually putting a date in my calendar. They had said that they would be flying, by a certain date in 2024, like a month. And so I put it in my calendar, like go to the East Coast and fly in one of these things. And of course, that didn't happen. And then ES in 19, the Hart Aerospace aircraft, which was originally going to be fully electric, right? And I'm thinking, wow, we're going to have two of these things. And yeah, so the way I've experienced the lull is going from that to aviation is now pretty silent, and ES30 is now sort of an independent hybrid electric. I'm hoping to talk to them soon. So I see a lot more parallel hybrids these days. A few series hybrids, the sort of EL9 and things like that. But yeah, I definitely see like a lack of ambition for battery only, I guess, is a good way to put it, except for maybe in trainers. Yeah. So that's how it occurs to me. Yeah.
Yeah, one thing that has happened in the last decade is that you take a battery, you push more and more energy into it. It's great for aviation, but also in a way it makes it unsafe.
Mm,
So you have to build more around it in terms of safety to contain that thermal propagation if there is one.
yeah.
So the benefit of having that extra energy density is kind of lost by having those extra components in there for fire suppression and stopping the heat propagation, etc., and having a very robust cooling system.
Mm,
So we've gone back to batteries that are more inherently safe. And that's what the EV world is using at the moment. So
Yep.
they've gone from lithium, from nickel NCM batteries, which is branch of lithium ion,
Right.
Right.
and from that they
Lithium,
moved on.
manganese, cobalt, I think.
Yes,
Yeah.
Yep.
manganese, cobalt,
Yep.
and nickel.
Yep.
And from NCA or NCM batteries, they've moved on to lithium ion batteries, which are safer, but then, the energy density is lower. So instead of 300 watt hour per kilograms, you are talking about 180 watt hour per kilogram.
Yep.
Um, but at the same time, they're much safer.
Yep.
So people realized when, initially when it came to EV, it was all about we want the range. But now people are realizing that they can do with less range, but they would appreciate the safety more.
Yeah.
So the EV world has gone in that direction.
Interesting.
Whereas for electric aviation, we would require batteries that are much higher energy density. And the only place where I'm getting positive news of progress is from China. So CATL
Mm-hmm.
has been developing a battery that they call the condensed battery. And if it comes to fruition, they've said that they have tested 2-ton jet on that, a 2-ton aircraft.
Oh, I hadn't realized that.
They've flown. Um, so, you, if you've seen the likes of Cessna Citation,
Hmm.
they've
Mm.
flown an aircraft of that size.
Wow. Okay.
But they have kept the data under wraps, so there's not a lot of information
Right.
available
Right.
Right.
regarding that.
The
But
citation is the business jet, if I remember right.
it's a business jet.
Yep.
Yeah, it's a
Yep.
business jet.
Got it.
They have kept a lot of information under wraps, so but I'm keeping a close eye on that space, and as soon as any information is available,
Yep.
I'll put it up on the channel.
I think of them. They've talked about an aviation battery, and I assume that's the same one you're talking about. I hadn't heard it called condensed, but the 2 tons is coming to mind as something I'd seen in their press release. Yeah, I think of them. I also think of Magna X. I think Magna X has announced like a 500 watt hour per kilogram battery, something, maybe 400. I'm
It's doable if they're making a solid state battery.
right, right.
A solid state battery with 500 per hour, watt hour per kilogram,
Yep.
is quite realistic.
Right, right. I like how you're taking it to safety. I've definitely heard people in aviation talk about, you can pull a car over, if you do have a thermal runaway event. And that's true. Not that I want my EV to have a thermal runaway event while I'm driving it, but I can pull over. And these things are somewhat slow. They're not explosive. They're so. It's I've heard it said that in aviation we need to prioritize safety more. It can't be a managed thermal runaway. It has to be no possibility of a thermal runaway, or at least very small. And I don't think I'd put two and two together that means energy density is the expense. I think of LFP in automotive as a solution to a price problem. But yeah, to your point, it's most likely also has a better safety track record as well. So I like how you're tying those two together. I hadn't seen that yet.
Yeah. Once I read an analogy, and that was quite nice. So I would like to share that.
Yeah.
Think of the battery as an aircraft and the energy inside it as the number of passengers. You can either put more seats and reduce the aisles, so you'll have more energy inside the battery. But when it comes to getting that energy out, it will be slower. Consequently, if you have more aisles, more gates, and you will have less passengers, but you can get that energy out quicker. So
Interesting.
if you look at the LFP battery, it is the battery which has more aisles to get the energy out quicker, so you can discharge it at higher C rates without any problem.
Ah.
And if you look at the other, high energy density batteries, yes, they pack in more energy, but it's relatively difficult to get it out.
Oh, interesting. So energy goes up, but power goes down in a way. Like you're
Yes.
interesting. Oh, I hadn't thought of that. That so there's another trade-off to your point. It's not just safety. There's something I wanted to get into with you around. Like, I still want to get to aluminum. We'll get to it. But another thing that's maybe equally science fiction or works in the lab, right? I don't mean science fiction. I mean it works in the lab, but we haven't seen it on the runway. Would be structural batteries. And I think this probably covers a range of topics from, using a rigid, battery module as something structural in order to absorb crash dynamics and things like that. Everything, but I wonder, could you see something where I don't know, a wing is made of batteries somehow, or literally the skin of the aircraft were somehow a battery. Like I don't like imagining things which are not feasible or just totally fanciful. But what do you know in this area? Have you followed much of the sort of structural battery area? What's promising? What seems far out but maybe possible? What do you think?
If you look at the batteries that we had, the shape of them,
Yeah.
so they were like cuboid, and how do you call it? They were basically like boxes, tin boxes.
Pouch cells.
Um,
Yeah.
yes, a pouch cell or a prism cell.
Yep.
But now, if you look at the some of the new layouts that are coming out, they are called the blade batteries, and they are much longer. So they are extended in their width, you can say. So the aspect ratio in one direction is very long. So it's almost like a wing shape. It has the same aspect ratio as a wing. So given that the new batteries are flatter and longer, you can adjust them easily inside the wings.
Hmm.
So they can be a part, the structural part, they can provide the structural rigidity, and we can pack more into the aircraft with a battery that has a form factor like that.
Right. Right.
So that's happening, and it's called the blade battery. They designed it so in your traditional EV skateboard chassis, you would have several of these batteries across the width of the car, but now you have just two of them.
Oh, I see.
That's yeah. So they are that long. With that form factor, you can also put them in an aircraft wing. I
So at
think it would
least
be a good.
to put in the wing, but that doesn't necessarily mean that they become structural to the wing. They're not. Um, yeah, I mean, you're certainly not. I don't know. I was almost imagining like a tubular containing cylinder cells or something like that, but the tube being something that was actually structural. But to your point, this blade battery is. I'm thinking of it like a longer pouch, almost like a
Yeah.
plank of wood. Is it to the point where you could use that as enough structural rigidity for the wing, or do you also have to have whatever components were there? Well, you probably need more to keep the extra weight up now, I guess.
Yeah, I suppose you can place them in the wing closer to the fuselage, but if you put them further away, you would have to structurally stiffen the
Yeah.
wing, which would defeat the purpose.
Right. Right.
But with these new blade batteries, it's easier to package them into a battery pack
Okay.
compared to the old ones. You have lesser connections. It makes it more reliable
Right.
compared to because each time you have to weld the terminal on top of the battery, there's a point of failure.
Right.
So with longer uh, batteries, longer and fewer batteries, you have lesser points of failure.
Cool. So another question I've got is like what's your favorite? Like I ask everybody what's their favorite aircraft, and we'll get to that on the lightning round. But for you specifically, since you've covered so many different things, I was just rewatching your Synergy Prime video, the DBT,
Yes.
and that thing is amazing. I mean, you've covered so many really interesting concepts, the Celera 500 and so on. Like, what stands out to you as like something that really captures your fascination?
Yeah, the Synergy Prime is a good candidate for you can say a family size aircraft. But if I were to look at a single person aircraft, then I like the pivotal helix,
Yeah.
uh, formerly called opener blackfly.
Mm-hmm.
And it's the simplicity of that design.
Yep.
It's quite beautiful because um, all these new eVTOLs have either a tilting wing or a tilting rotor. Well, it doesn't have that. It just tilts the whole body up.
Yep.
So you've taken out that complexity just by clever design. And it's got 8 motors, and the motors are basically the main recipe of their success because the motor weight is just 2 kilograms, and yet it delivers about over 40 kilograms of thrust.
Wow. Wow.
Uh, yeah, and they've got 8 of them. I sometimes am daydreaming about this scenario where there's a zombie apocalypse and I find myself little black flies hidden somewhere away, and it helps me to survive. I make these stories up in my mind. So yeah, that is my one go-to aircraft. It's a shame that I can't afford it.
We'll have to see if we can get them to sponsor your channel.
Maybe.
That could be fun.
But yeah, another point, technical point that it kind of helps that aircraft is that every motor has a battery behind it, battery module right behind it. So they don't have like these these power cables running to every single motor. So if you have your battery right behind your motor,
Mhm.
you essentially eliminate that weight. So they've
Yeah.
got like 8 smaller packs, and
Hmm.
only the wires that kind of control those, batteries regarding how much power that has to be delivered. Those thinner wires go all the way to the controller.
I didn't
As
realize
far as
that.
main power wires are concerned, your bus bars are concerned, they sit right behind the motor. So it's a very short path
Wow.
from between the battery and the motor.
Well, and I imagine
That's
control
where they
cables would.
also save weight.
I imagine the control cables would be lighter, right? So the only cables that you do need are what are lighter now. Okay, so instead of sort of a single monolithic battery in the fuselage, it's instead distributed batteries, one per. Oh, I didn't realize that. Cool.
Yeah, so there are 8 of them, so one for every motor.
Very cool. Okay, cool. Good answer. Good answer. I like that. So we've kind of come to the present, and we've talked a little bit about like my interesting future stuff. Now I have to ask about aluminum air one more time though. I'm so glad you mentioned it. You hadn't I haven't seen you cover it since, so I wondered if maybe you weren't thinking about it again. But you mentioned it earlier, so you have to tell me like what do you think of these? If so, let me see if I remember how it goes. Something like an iron air battery. It's essentially the process of oxidation in reverse, right? And it
Yes.
can
Yes.
store and generate electricity through the chemical process of air being exposed to the aluminum. What my fuzzy memory took from that episode, and I wish I'd rewatched it now, is that essentially you have to completely recycle the materials upon every flight. Like that, there's no recharging an aluminum
Yes.
air battery.
Yes.
So which is
You
why
can't
it's
recharge.
maybe more of why it's better to think of it as a fuel cell, because there's no recharging, there's only recycling. But if I remember, there's these companies making these little sort of metal discs that you could sort of easily load into a cell and perhaps easily
Yeah.
unload. So like, okay, I've done my bad impression of this. Like, tell me how it really goes, and then tell me what you're seeing.
Well, basically, you have a bunch of aluminum plates dipped in an electrolyte. And what happens is, as the aluminum oxidizes, it produces electricity, and from aluminum oxide, and that kind of breaks away from the plate that you have. It's like a rust that happens. It mixes with the electrolyte. So you have to also keep flushing out the aluminum oxide. So as more and more power is drawn, these plates dissolve away. So when you land or when you've done your mission, all you have to do is replace them with fresh plates, fresh aluminum plates. and that's it, you're good to go. So recharging it is not a problem.
Mm,
You have to have some place to kind of, that recovered aluminum oxide solution that you have remaining. You have to keep that so that you can recycle it.
mm.
Although that recycling process is energy intensive, but uh, the benefit of that battery is you get 4 to 5 times more energy density compared to um, what you have right now.
What
And
about
What?
power
and
Right.
it,
density?
sorry,
Do you still get the power density you need also?
we do get the power density with it. Um, so there has been an aircraft in the UK called Swift, and it has flown using that.
Wow.
So I was to go and see the demonstration for it, but unfortunately, it didn't come to fruition.
Oh no.
Yeah,
but, but they did manage to
I mean,
fly
the
it.
flight did happen, but I wasn't there to
Wow.
witness and record it. Yeah.
Oh well, you must have. I'm kicking myself because downtown Toronto over the last 2 days, Horizon, the company who's making the EVTOL with
Yes.
the where they close the veins so
The
that it's
Verizon, is it Cabaret?
yeah,
The
yeah, Cavorite.
aircraft is called.
Yeah,
Yeah.
they had the Cavorite X7 mock-up down just downtown, like on the street, as part of a celebration for mining and minerals or something. I don't know, a conference I think. And I'm kicking myself. I wish I'd gone to see it. So I can relate to the feeling you're having about not having been there. But you're saying they did get to fly it though. That's awesome.
Yeah, they did.
Okay, just a once
I
or did
can't
they?
remember the flight time, but it was, more than an hour. They were
Awesome.
airborne for.
Wow, that's pretty impressive.
One thing you'll see a lot of development is in electric aviation is the two-seater trainer aircraft. So just like the Pipistrel Vallis Electro, you'll see at least 5 or 6 other aircraft that will um, join the Pipistrel Vallis in the near future. I know for sure there is Buy Aerospace. They
Yep.
have E-Flyer. And why? Because it's quite cheap to run it. So you can charge it up for about uh, under $5 easily. Whereas, for most of the other, you can say similar aircraft like the Cessna 172, you might have to fill high octane for that
Right.
or F-gas, which is, quite more expensive than just $5 worth of
Yeah,
Yeah.
electricity.
yeah,
So it makes economic sense for a lot of training schools, flight training schools to have that. Also, the maintenance requirement is pretty low. With the engine, every now and then you have to send it for servicing and overhaul, etc. With this one, you can have motors flying for years without needing anything to be done on them.
right. Yeah, I'm definitely seeing it take off on skyzero.io, the website where I track this. Like, trainers are definitely the thing which fly the most, right? The Pipistrel Velis and Alpha are hands down like racking up more miles, kilometers, nautical miles, whatever you want to call it, than anything else right now. And to your point, I think they're really catching on. E-Flight Academy in the Netherlands flies these exclusively. Something Aviation in Fresno in California has 4 of these. Yeah, I mean that's the two off the top of my head. I think there's another one in Pitt Meadows and British Columbia. There's a lot of different flying schools that are going this way. Yeah,
It's easier to also get it certified because it's just a conventional
Yep.
aircraft with a motor instead of an engine,
yep,
an IC engine.
yep. Well, and to your point, Age 55 and BRM Aero with the Bristol Energique recently got that
Mhm.
certified in not only EASA but FAA2 now, if I remember right. I think Mosaic helps with that, but or
Mhm.
they might have certified it under Part 23. I'll have to check. But yeah, you're starting to your point. There's definitely a lot of options in that category, and I can see it growing.
Yes.
Yep.
Yes.
What stands in the way of something like aluminum air getting to the next step? When you think about what's blocking us, what's holding us back, what comes to mind to you right now?
I think it's just awareness. And once, it has more eyeballs and people know what it is, a lot of people would just dismiss it. Oh, it doesn't recharge.
Yeah.
Yeah. I don't want to know about it.
Yeah.
But they're overlooking the benefits of it. It's very safe. It gives you 3 to 4 times at least more energy for the same amount of weight. You can charge it back up very, very quickly, fill it back up, whatever you want to call it. So I think once there's more awareness around it, then people will start adopting more of it.
Yep.
That's the only hindrance I see.
Hmm. Very cool. You make me want to take a swing at it for sure. Um, so, what else do you think is in the future? I mean, we've talked a bit about the present, and we've talked a little bit about what's coming next, and some of my favorites in terms of aluminum air and structural batteries and so on. But what do you think? What will we see in 10 years, just to pick a number out of a hat?
I think we'll see a lot of hybrid aircraft. And the reason we'll see them is because they're the best of both worlds. They make use of the efficiency that electrical propulsion offers, um, and also they give you the range because of the hybrid turbogen system. So you can have a turbo generator, and Rolls-Royce is developing it. There are other companies that are developing it. I think Honda is developing their own.
Mm-hmm.
So the idea is to have a turbo generator that would deliver you all the power you need. And we've seen that they've developed it till the scale of megawatts.
Mm.
So your normal eVTOL, like you can say vertical aerospace or Joby or Archer, they require maximum of 600 kilowatts to fly while they are hovering. So these gensets or turbine generators, sorry,
Mm-hmm.
they are in the megawatt scale, so they can provide not 600 but 2,500. So they even Joby can fly with them.
Mm.
And the good thing about them is they are very light in terms of their power density.
Mm. Yep.
So they pack punch, so they deliver a lot of power for electrical power for their weight. So what you will be seeing in the near future is we won't be having many pure battery electric aircraft. Yes, they will have their role kind of in maybe four-seater 60-mile category. But if you want to go further, like hot aerospace or aviation Alice or many others, then you might see the turbine generators inside these aircraft that are delivering power to electrical motors rather than
Mm.
IC engine driven propellers. We will certainly not replace the jet engine in the near future. So any aircraft that use jets, they're still kind of, they will be unhindered by this development. But aircraft that are using small internal combustion engines, Cessna Caravans, for instance, or smaller plane, general aviation aircraft, I see a lot of changes in the general aviation aircraft category.
Got it.
So that's the future because, uh, you know, your internal combustion engine at most can be 25% efficient, whereas your electric motor goes up to 95%
Yep.
efficiency. So you're almost more than 3 times more efficient in energy from your internal. If you compare the internal combustion engine to a motor, electric motor driven propeller.
Clearly, we had Ed Lovelace on the channel last month, and we were talking about just that. And we talked about sort of independent hybrids, like the ES30, where you've just got independent propulsion systems. We talked about series, where I think Viridian's going this way, where they're going to have a small turbo generator only if they need it for VFR reserves, or IFR reserves, I should say. And there's other, EL9, for instance, is also a series hybrid where the turbo generator charges the batteries, and the battery then drives the 8 distributed propulsors, 4 on each wing, if I remember. But then he was talking about his Echo Caravan, where they've taken more of a parallel hybrid approach, where essentially the combustion engine is driving the propeller all the time. And they also have electric motors in there. And I think the engineering thinking going into this is to say, okay, if we can have an electric motor to provide maximum thrust at takeoff, right? When we need 100% power, when throttle goes to 100, then your combustion engine is going to be at max RPM, and also the electric motor will be kicking in at that rate. And this allows us to use a smaller piston engine than we would have, which means that once we do pull back to, say, 70% for cruise, then that combustion engine it'll be perfectly sized for its job.
It will be optimized for the cruise path.
And he would go on to make the point, if I understood him correctly, that when you do a parallel hybrid, or even when you do a series hybrid, you need to charge the battery, and you have some small losses there. Inverters aren't perfect. And then, to your point, there's a small loss between the battery and the DC motor. If it's a DC motor, small, but not much. And worse, if it's a DC battery and an AC motor, then you also have extra conversion losses. Of course, you can just avoid that mistake. But he would say that the parallel hybrid allows you to not have to worry much about that extra wasted combustion energy. But I'm with you. At the same time, like, clearly electrical motors are more efficient in themselves. Clearly, there's no doubt about it. And I think the point he was trying to make is that in a 2-prop or 1-prop system, which the Echo Caravan is a big single prop, obviously, that the added efficiency is worthwhile. When you get into something like the EL8, or EL9, I should say, with the 8 propulsors, no, go series. Because you're not going to put 8 separate combustion engines on it. It just doesn't make any sense.
Yes.
So it was interesting to hear you go in. So are you making the assumption that distributed propulsion then, when you're talking about series hybrids like that, or what do you think?
Let's say distributed propulsion. It's obviously all electrical. So you will have. It doesn't make sense to have distributed propulsion with conventional propellers driven by ice. Although there is one instance where that has been done, and it was Howard Hughes with his epic plane back in the early days of aviation, the Spruce Goose, I think it was called.
Yeah, okay.
So it had multiple propulsors on its wings, and he managed to achieve liftoff, but it didn't go very far. To take the benefit of the electric motors, which are really low weight and provide you massive amount of thrust, then you you can have a battery-based systems for that, or you can have a battery that is backed up by an electric generator. Um, or also one thing that is often comes in the way of a hybrid system is the noise that the generator will produce.
Mm,
So it depends if you want to have a noisy aircraft or not, because once the generator kicks in, it will produce its own noise
right.
because it's a turbine generator. So if you have a pure electric propulsion system, then yes, you have low noise.
Yeah.
That's the advantage.
For urban, you definitely want something more, which is battery driven, if you can get it, to your point. Yeah,
Yes.
that's definitely true. Okay, so this is our future. We're definitely expecting more hybrids. I think you're right. I will say I'm looking forward to maybe getting to jet-based hybrids down the road, but there's a number of materials challenges to solve before we can do that. Can I ask something you're most proud of, either in your career so far, with ground-based vehicles, if I remember right, or with the channel. Like, yeah, what are you most proud of?
I think I did a video called Batteries for Electric Propulsion, and I was contacted by the FAA, and they asked me if they could use that as training material for
Wow.
their program. So yeah, I was proud about that. So I always wanted to contribute to the aviation world. It's such a passion of mine. So when they asked me that, I was really delighted, over the moon about it.
That's amazing. That's amazing. So, like, when you getting onboarded there or going to a program, that's too cool.
I have to mention this though, that the FAA is behind in this new mode of propulsion. Um, they are more reactive than proactive. Whereas in China, we see something, totally vice versa. So over there, they're helping out, the regulatory body is helping out their um, eVTOL and electric plane manufacturers and giving them the tools and leeway they
Yeah.
need.
Yep.
Whereas over here, I would say they're at least 1 year behind the development. So that's why certification is a challenge,
Yep.
and it will be for aircraft like Joby and Archer and
Yep.
others that follow this route. So
Yeah, for sure. It seems to me that EASA and maybe UK's CAA are in the middle. They're not supporting it as much as China is. I mean, that's
yeah, they're
amazing.
all
But
kind of sitting on the fence with this one,
yeah,
and they're not really embracing this technology.
yeah,
Is sometimes I feel that they're waiting for something bad to happen, and then they'll say, "Oh, we want to close the chapter on this one. We don't
yeah,
want to go that route."
yep,
I get the feeling sometimes that's the case. It may not be, but yeah, they should embrace this technology, because this is the way the world will go. And with destination zero, and you want to go low emissions by 2050, this is the way that provides you
yeah,
the way that will take you there.
yep. I think one of the things that you've done that's inspiring me the most just this moment is the solar cargo. Anything I think we can do that takes trucks off the road in terms of
Yeah.
moving cargo around could be very impactful, right? I mean, and it may be a while before we have something that can carry 300 passengers across the Atlantic Ocean. That may be a while. But man, if we can start to take trucks off the road with something like that, that could be amazing.
Yeah, one thing that is quite interesting, and it's happening in the solar energy world, is that the energy efficiency is climbing for solar cells. So, if you remember the planet impulse, solar impulse that happened
Yeah.
in 2015,
Yep.
it was an aircraft that circumnavigated the globe with just solar energy, and it flew day and night. So, the cells that were on it were about 23% efficient.
Right.
The cells that are now available are about 30% efficient.
Right. Right.
So straight away you have a 7% efficiency advantage.
Right.
And they're saying with triple junction solar cells,
Right.
you can go up to 40% efficiency. 40% of the sun's energy would be converted into electricity. That means you'll have more power. The solar impulse went very slowly. It was a very slow aircraft. I think it did about 50 miles an hour, 60 miles an hour. And that was because it was so large. Its wingspan was that of 747. If you can make the aircraft more compact, you have more power per unit area, you can go faster. And that will make the design more practical. There have been many aircrafts that have used solar energy. Uh, and I think there is the Stratoflyer that was developed in Switzerland that flew. There's the E Flyer again in
Yeah.
USA that did coast to coast. on solar energy,
Yep, yep.
and light is
Gliders.
solar impulse. So once you have, once you take this development in the world of solar cells on board on your plane, so you have about 40% efficiency cells on top. You have more power at your disposal.
Yeah.
You can make a smaller plane that goes faster, and you can use it to deliver payloads. You can have autonomous aircrafts that
Right,
will be
right,
doing your mid-mile logistics.
right, right. If you don't have to carry, 100 kilograms of pilot and how many
Yes.
kilograms of safety system and everything else,
Yes, exactly.
pressurized cabin, all of a sudden that can all be cargo instead. Yeah,
Yes, exactly.
yeah.
Yeah.
Exactly.
So yeah, I think UAM and solar in combination have got a really interesting future. What about something you've learned? Is there something that you thought was true when you started this journey that you have since realized wasn't what you thought? Any learnings like that?
I had a lot of faith in many battery chemistries, and that have never come to fruition.
Mm,
I thought that when I started the channel that lithium sulfur battery, this is it. This is what we need. But again, it has got its own challenges.
hmm.
Although, even though it was providing like 400 watt hour per kilogram 10 years back, and I think it still provides that, but it had some inherent safety and life cycle issues.
Mm.
The other thing is solid state batteries. So I've been hearing this that they are just around the corner, just around the corner,
Yep.
and that didn't happen.
Yep.
A couple of disappointments that I had was with Lilium.
Mm.
I really liked the design,
Yeah.
but unfortunately, I don't know what their current state is, but I don't think they're very financially
Right.
stable right now.
Right. If I remember right, Volocopter got acquired by the same company that owns Diamond. But I think, yeah, I don't think anything good has come for Lilium yet. There's been a couple of buyers who've come out of the woodwork, but then not done anything. So yeah.
And one thing that I used to think in a certain way, but that thinking has changed. I saw a comment once on Lilium, and it was that things that have a low, very high disk loading, which Lilium had, means it had a high number of small propulsors,
Mm-hmm.
right? And Volocopter had that too. Several propulsors, but small disk area, you can say.
Right.
Any aircraft like that would consume tremendous amount of power
Mm.
to get off the ground.
Right.
He was an aeronautical engineer who had been in the field for a long time, and he said that Lilium will never take off the ground, and because it has some inherent design problems.
Mm.
And at the moment, I thought, no, you know, it will definitely, because I've seen the flight happen and I've
Yeah.
seen the test flights, and
Yeah.
you know, so it's definitely, and I've wanted that person to be proven wrong, but
Oh.
unfortunately, it wasn't to be.
Yeah.
So this is conventional wisdom that he has learned over the years,
Yeah.
that if you have rotors that are large, and they push down air slowly, uh, you require a lot less power to get your lift
Got it.
compared to several small propulsors that require too much power. Any startup, when I see any new design, now I gauge that design based on the disk area or the disk loading, and that gives you a clue if it's going to fly or not.
Interesting. Cool. Cool. Okay, I will bring us into our lightning round, and so this is meant to be the same couple of questions that I ask everybody. And I asked you earlier what your favorite aircraft was, and I think that's very much yeah, and you mentioned the Pivotal, so you can use that again if you want. But but I'll ask you again. What's your favorite aircraft?
Let me go back to this and see if I can find another one, another favorite of mine. Um, the Jetson one, I really like it uh, because although it's just a drone with a person sitting in between. Um, but in terms of, I feel like flying it is very quite fun because it's very responsive, it's very compact. You know, you feel like just like in a go kart, you feel like you're out there. So um, Jetson one is another favorite of mine. You can say
Cool.
it's very simple. Yeah, the flight time isn't great, and safety wise, perhaps a lot of people would say that they don't like the sight of open blades
Yeah.
and an open cockpit. But I see that it's very responsive. They often release videos, and I think they released a recent one where they're going around obstacles. I don't think the pivotal helix would be able to do that. It's not
Mm.
very responsive.
Mm.
There's a delayed response with that. But
Yep.
Jetson 1 was able to do that. So, in terms of fun of pure flying fun, I would opt Jetson
Nice.
1.
Nice. Okay. What about a favorite airport?
I really like the Schiphol Airport in Amsterdam.
Mm-hmm.
I think it's quite nice. Um, I've traveled from there at least a few times. And Dubai used to be my favorite airport before that. Yeah, I was a frequent flyer. I've frequently flied using Emirates, but I think it's become very pricey,
Yeah.
so can't afford it now.
Yep. Everybody agreed with you, pushing the prices up. Okay, one more, and this one is more personal to you, or and just your interest in general. Is there anything you want to give a shout out to? Anything you want to? Maybe it's content you made that you're really happy about or excited about, or maybe it's content somebody else made that you're really loving. Any shout outs?
I like Real Engineering channel. I think they do really good videos. Mustard, I really like them. Yeah, but these are big channels already. They don't want my shout out probably. But yeah, they do inspire me to make more videos. And they spend quite a lot on their graphic design,
Yep. Yep.
on their graphics, which I don't. My my videos are pretty grounded, I would say, compared to them. But yeah, I do follow those channels.
Yeah, no, I agree on both of those. Oh, who's the guy that's often doing stuff about bridges? I want to say his name is Grady, and I don't think it's real engineering. He's similar to real engineering. He covers more stuff than just bridges, but I think he was a hydrological engineer, so I think that's what his sort of speciality is dams and bridges and this kind of thing. Yeah, I'll have to look up the title, but yeah, that's one of my favorites right now too. Well, Haroon, thank you so much for your time today. I really appreciate you making time to come on and talk to us about electrified aviation. This is great.
Thanks for having me. It was a joy to speak to you
Okay,
regarding this.
all
You're
right.
very knowledgeable as a host, so which helps.
Oh, yeah, you're being kind, but yeah, thank you. Appreciate the compliment.